All right, let's just jump right in. Look, if you've ever trained a machine learning model, you know the feeling, right? That special kind of pain. You hit run, you watch that compute meter just spin and spin, and you're basically just crossing your fingers, hoping you pick the right settings. Well, today we're going to break down how to train smarter, not harder, specifically in Azure machine learning.
I mean, this is the million-dollar question, right? And sometimes it's literally a million-dollar question. Finding that one perfect model with the perfect parameters, it can feel like this endless, super expensive guessing game. You're just trying to land on that magic combination, but every single guess costs you real time and real money. So how do we get out of that loop?
So in Azure, it pretty much boils down to two main roads you can take. Think of it like a fork in the road. On one side, you've got AutoML. That's basically you handing your data to Azure and saying, hey, you're the expert, you figure out the best model for me. Then on the other side, there's Hyperdrive. This is where you come in and say, okay, I've already got my model script, I know what I want to use, now help me fine-tune it to perfection. And honestly, choosing which of these paths to take, that's your first and maybe most important decision.
Okay, so let's walk down that first path, automated ML. I like to call this the hands-off approach. Think of it as your express lane to getting a really solid baseline model, especially when speed and simplicity are what you're after. You know, the real magic of AutoML is that it takes on all the grunt work. All that tedious, iterative stuff, trying out algorithm after algorithm, tweaking all the little settings, it just automates the whole shebang. It just churns through all the possibilities, and at the end, it basically just hands you the winning model on a silver platter.
But here's the thing. Automated doesn't mean you just press a button and walk away. You still have control. You're the one who sets up the critical guardrails. For instance, you define the task. Are you doing classification or maybe regression? You also set the primary metric, which is how you tell AutoML what best even looks like to you. You can let it handle the data featurization automatically, getting all the raw data ready. And you can even tell it, hey, don't even bother with these specific models. You're still the director. AutoML is just your super efficient crew.
All right, let's switch gears and talk about path number 2, Hyperdrive. Now, this is your go-to when you already have a model script in hand, and your goal is to tune that thing to absolute perfection. It's less of an automated scout and more of a precision workshop.
So when you step into the Hyperdrive workshop, you've got two big decisions to make right off the bat. First up is your search strategy. I mean, you could have this massive, almost infinite space of possible parameter combinations. So the question is, how are you even going to begin to search for the best ones?
You basically got 3 main flavors to choose from. First, there's grid sampling. This is the brute force, leave no stone unturned method. It tries every single combination, so you really only want to use this for small, manageable search spaces. Then you have random sampling. This is way faster. It just picks random points, and it's surprisingly good at finding a great solution pretty quickly. And finally, there's Bayesian sampling. This is the brainy one. It actually learns from each run to make a smarter guess on the next one. But, and this is a huge but, it has a critical weakness. You can't run it in parallel.
Okay, your second big decision is all about saving money and time. Efficiency. Think about it, every training run costs you compute credits, so if one of them is clearly a dud, just performing terribly, why on earth would you let it run to the end? You wouldn't. You need a policy in place to automatically pull the plug on the bad ones.
And for that, you've got a few options. First is the bandit policy. This one is super aggressive. It'll stop any run that isn't within a certain margin of the best performing runs so far. Then there's median stopping. This is kind of your balanced, middle-of-the-road choice. It stops a run if its performance is worse than the median of all the runs up to that point. And finally, you have truncation selection, which is maybe the fairest of the bunch. It just periodically looks at all the runs and chops off the bottom percentage, say the worst performing 20%.
Okay, that's enough theory for now. Theory is great, but it's time to see how this stuff actually works in the real world. So let's get our hands dirty and walk through a few scenarios to really make these ideas stick.
Scenario number 1. Imagine you're working on credit card fraud detection. Now, the key things to know are fraud is super rare, which means your dataset is massively imbalanced. And your number one goal is to catch every single possible case of fraud. You'd rather have a few false alarms than let a single fraudulent transaction slip through.
So with that in mind, you're firing up an AutoML run. What are you going to pick for your primary metric? How are you going to tell AutoML what a good job looks like in this specific case?
The answer you're looking for is normalized macro recall. And here's why that's so important. Accuracy is a total trap with imbalanced data like this. Just think, if only 1% of your transactions are fraud, a model could just guess not fraud every single time and be 99% accurate. but it would be completely useless, right? Recall, on the other hand, focuses on one thing. Of all the actual fraud cases that happened, how many did you find? And the normalized macro part just makes sure it's doing a good job across the board. It's the perfect metric for this job.
All right, on to scenario number 2. This time we're in the hyperdrive workshop, and the pressure is on. You've got a tight budget, a huge search space with tons of parameters to check, and the clock is ticking. So you absolutely have to run your tuning jobs in parallel.
So, thinking back to our 3 sampling methods, which one is the obvious choice here? It's gotta be random sampling. Let's just run through the logic. Grid sampling? No way. With a huge search space, it would cost a fortune. What about Bayesian? Well, it's smart, but remember its fatal flaw? It can't run in parallel. So, it's out. That leaves random sampling. It's fast, it's perfectly happy to run in parallel, and it's great for exploring those big, complex search spaces.
Okay, last one. For this scenario, you're being super aggressive about cutting costs. You've laid down a strict rule. If any training run is performing more than 10% worse than the current best performing run, it gets shut down. Immediately. No questions asked.
So, based on that very specific rule, that 10% margin, which termination policy are you going to pick?
That, my friend, is the textbook definition of the bandit policy. That slack factor, or that specific 10% margin, that's its signature move. Anytime you see a rule that says stop if you're not within X% of the leader, you know you're dealing with the bandit. It's the most aggressive, and it's built for exactly this kind of scenario.
So let's just boil this all down to the core takeaway. It's actually pretty simple. You use AutoML when you need a solid baseline model fast, or when you're just not sure which algorithm to even start with. You use hyperdrive when you already know your model, you have your script, and you're all about meticulously tuning it for maximum performance.
And there you have it. That's the breakdown. You now have a really clear framework for deciding between the automated power of AutoML and the precision control of hyperdrive. So the only real question left is, on your next project, which path are you going to choose?